Hello, good people, and welcome back. We are still working on Unit 9 and that's on swaps. And in the last video, what we did was working on this example where we computed the value of a swap agreement. Now, this swap agreement that we worked with was entered into at some point in the past, and we were finding its value at this point here. So that's what we were looking at. So it has a positive value. It could have a negative value here. But when the contract is entered into, it has a value of 0, right? That's what we know for a swap agreement. Now, what we want to be able to do is to assume that we don't have we don't have this LIBOR rate, right? This anticipated LIBOR rate. What if we cannot use this method to find the LIBOR rate? What other option is available to us in order to estimate the forward LIBOR rate? And the method that we're going to be using here is going to be the bootstrapping method. And now you remember bootstrapping. It's a method that we use to generate our zero curve a couple of units ago. And we're going to be using a similar method here in order to estimate what the forward LIBOR rate or LIBOR forward rate is with this example that we have here. All right, so let's get this started and play with this for a second. Now the example says that we have a zero curve that's given to us. Because I see the OIS rate here, I know that's my zero curve, and I have my maturities to 6, 12, 18, and 24, and I have the rates 3.8, 4.3, 4.6, and 4.75. Now the OIS rate or the zero curve is continuously compounded, that we know. The LIBOR rates are semi-annual compounded, and the 6 months LIBOR rate is given to us at 4%. The forward LIBOR rates are computed for the 6 to 12 and the 12 to 18 month period, and they are 5 and 5.5%. Now these rates are also semi-annual compounding, right? We also told that the 2-year swap rate is at 5%, and we are asked to find what the forward the LIBOR forward rate, which we're going to label F, is for the 18 to 24 month period. All right, let's get this together. Let's collect our data and get started with working on this. So we remember that we are given our OIS curve. I'm going to start with the OIS curve, and we have the maturities T, and I think they were 6, 12, 18, and 24 months. So that was a 2-year swap, and the OIS rates, so OIS rates, were given at let's go back to the slides and see that 3.8, 4.3, 4.6, and 4.75. So we're going to go back to our board here, and we're going to say 3.8%, and we're going to say 4.3%, was that 4.6%, and finally 4.75%. So this is going to be my zero curve here. Next, we are told that the LIBOR rate for the 6 months maturity, which is this maturity here, has been computed. So we can essentially say LIBOR was computed here and was at 4%. And I'm just going to do this. That's my LIBOR rate at 4% here. Now we need to remember that the OIS rate are continuously compounded, where LIBOR is semi-annual compounded. Okay. Now we are also told that the forward rate LIBOR have been computed for us, and they are 5% and 5.5% for the 612 and the 1218. So 5 and 5.5%, which means that we were lucky and somebody computed this for us, and that was 5% and 5.5%. And we know that these are forward rates. And what we're asked to find is what is the rate for this last period, right? The 18 to 24 months period. That's what we're asked to find. And finally, we said, well, what is the value, of course, of this swap agreement? And what we're going to do here is we're going to assume a scenario where the swap contract looks something like this. This is the first party and this is the second party. With an interest rate swap, which is what we are working with here, one party is going to be receiving LIBOR and making a fixed payment. So we're going to have a fixed rate that's going to go from this party to that party, and we're going to have, in exchange for that fixed rate, we're going to have LIBOR that's going to come in. So we're going to get LIBOR here. So let's say that's the scenario. Now we're not given, I don't think we're given a notional amount. We are not given a notional amount. Oh, there we go, here. A 2-year swap where 5% is paid, where 5% is paid and LIBOR is received on a $100 notional amount is worth nothing when it's initiated. So we're working a 2-year swap, 5% and $100 notional amount. So let's go back here and say, well, our notional amount, remember we call that M. I'm just going to use M here for my notional amount, is 100. And we said that we are paying 5% and we're receiving LIBOR. So we're going to pay 5% here for our swap rate, and then we're going to be receiving LIBOR. And remember, the swap is a fixed rate. And so a couple of questions. First, what is this LIBOR rate? And what is the we're going to infer then what the value of the contract is. Now, because we are at the initiation of the contract, we know its value is going to be equal to 0, right? Because a swap agreement is worth 0 when it is entered into. So our timeline is going to look something like this. We're going to have today, going to have 6 months, 12 months, 18 months, 24 months. So 6, 12, 18, 24. And with this, there we go. With this, we know that our swap rate, which is a fixed rate, is going to be 5%. Now remember, all these rates are annual rates, right? So we're going to use 5% here to represent our swap rate. But remember, these are all annual rates. So we're going to divide them by 2 always. So that's 5%, and that's another 5%. Those are our swap rates for those periods. In exchange for that, we're going to be receiving LIBOR, and we know that LIBOR for the first 6 months is going to be 4%. That's what we're given here. So LIBOR for the first 6 months is going to be 4%. We also know that LIBOR for the period that is going from the 12 to 18 is 5. Now the 60 to 8 to 12 is 5%, so 6 to 12 is 5%. That's that one here. And then 12 to 18 is 5.5%. So 12 to 18 is going to be at 5.5%. and we are asked to find what this rate here is for this last period that we have. What is that LIBOR rate there? Alright, and you remember how we find the value of a swap. If we know that the value of a swap here is equal to 0, it simply means that the present value of all the cash flows that I receive at this point, so we're going to find the first cash flow, find its present value, plus the second cash flow, find the present value of the second cash flow, plus the third cash flow, find the present value of the third cash flow, which occurs here, and then the last cash flow, this 4, that occurs here, and then we're going to find its present value. That means that the sum of those present value of the cash flow is essentially equal to 0 because the value of the swap argument is equal to 0. And therefore, what we're going to do is figure out what are those cash flows and how it is that we compute those present values. We're going to call this rate here, we gave it a name, we're going to call that our forward rate. So I'm going to say that is F here. And we're going to try to estimate what that forward rate is. That's our goal there. Forward LIBOR rate, because these are the LIBOR, these here are LIBOR, and those there are our swaps. Okay, and those are the fixed rate LIBOR rate. Now, what are those cash flows that are going to be received over these periods? Well, what we're going to do here, we're going to say cash flow 1 is going to be equal to our notional amount, which is 100. Actually, start with what we have here. We're going to be paying 5% and receiving LIBOR. So what we're going to do is we're going to be receiving LIBOR 4% and going to be paying swap rate, fixed rate 5%. We're going to do that semi-annually, so we're going to divide that by 2, and we're going to be paying that on a notional amount of 100 million. That's 100 here. Once we have that, we need to find its present value because that's our cash flow. We need to find the present value of our cash flow, so we're going to multiply by the exponential of minus. The rate that we're using to discount here is our OIS rate, so that's going to be OIS rate. And our OIS rate for a maturity of 6 months is going to be 3.8%. So we're going to do 3.8% multiplied by 1/2, because 6 months is half of a year. Now, what that's going to give me is going to give me, I'm going to call that 1 here. It's going to give me my first cash flow here. And then what I'm going to do is to find the second one. So the second cash flow, which is that one, is going to be very similar. Now, what are we receiving? We're receiving LIBOR, and LIBOR this time is equal to 5%. So we're receiving 5% LIBOR. We are paying 5% fixed for a semi-annual period on a notional of 100, and then we find the present value. The OIS rate for a maturity of 1 year is 4.3%, so that's going to be 4.3% multiplied by 1. The third cash flow that we have is essentially going to be equal to, we are receiving LIBOR at 5.5% minus the fixed rate of 5% divided by 2, notional amount 100, and then present value. And the present value, our 18 months OIS rate is 4.6, and that's what we have here, 4.6 for our OIS rate. So that's going to be 4.6, and we're going to do 18 divided by 12. Alright, that's 4.6%. And our last cash flow is going to be LIBOR that we're going to be receiving, and that's what we don't know, so we're going to label that F here. That's what we're going to be receiving. We will be paying fixed rate, which is still 5%. That's our swap rate divided by 2, multiplied by our notional amount of 100, and then we find the present value at the OIS rate of the period, and the OIS rate of the period is 4.75%. So it's going to be 4.75% for 2 years. Alright, so what do we have? We know that the sum of this present values is equal to 0. So what we're going to say is 1 plus 2 plus 3 plus 4 is going to be equal to 0. So that puts up one equation, one unknown, and then we simply solve for our forward rate. Alright, so I'm going to bring my financial calculator and get this started. So I'm going to pull that here, and I'm going to start with the first one. So with the first one, I have 4 minus 5 equal divided by 2 equal, and that's 0.05%, so that's 0.005. I'm going to multiply that by 100 equal 0.5. Alright, that's 0.5 that I'm going to multiply by the exponential term there. So my exponential term is going to be 3.8% minus divided by 2 equal, and I'm going to do the exponential of that, so second function exponential. That gets me that, and I multiply that by 0.5 minus equal, and that gives me 0.49, let's see, 491. I'm going to say equal to 0.491, and the second one is going to be as follows, is going to be 5% minus 5%, that's 0, so the second one is going to be equal to 0. We don't have to do that. The next one is going to be 5.5% minus 5, that's going to be 0.5% divided by 2, so 0.5 divided by 2, that's going to be 0.25. And our 0.25 is going to multiply that exponential term that we have there. So our exponential term is going to be 4.6% times 18 divided by 12 equal minus, and then second function exponential, and we're going to multiply that by 0.25 equal, so that gives me 0.233, so about 0.233. And the last one is what I don't know because I don't have my forward rate. So I'm going to call that last one, I'm going to leave that last one alone. And what I'm going to say is that my forward rate, which is what I'm after, minus 5% divided by 2 multiplied by the notional of 100, present value at 4.75% for 2 years, plus, let's just do the plus here, 0.233 plus 0 minus, because it's a minus sign there, 0.491, all that is going to be equal to 0 because the value of my contract here is equal to 0. And of course all I'm doing is solving for my forward right there. Now the sum of these two here gives me the following. We have 0.233 minus 0.491, that's going to be minus 0.258. So we're going to do minus 5% divided by 2, 100 exponential of minus 4.75% times 2 plus, is it a plus or a minus? I think it's a minus, minus 0.258 minus 0.258 is equal to 0. So that term there is going to be equal to, and remember we have our forward rate here still. And so we can simply continue to solve. What we're going to do is, what we're going to do next is our forward rate. Now I'm trying not to skip steps here. So actually I can skip steps. Forward rate is going to be equal to 2 times our 0.258 divided by 100 multiplied by exponential of 4.75% times 2. We ignore the negative sign because we're multiplying by, and to that we're going to add 5%. There we go. So let's compute this. We're going to have the following: 4.75% multiplied by 2 equal, we're doing the exponential, we multiply by 2, we multiply by 0.258, we divide by 100, we add 0.05 equal. So that gives us about 5.56% for our forward rate, LIBOR rate. So our forward LIBOR rate is going to be equal to 5.56% approximately. Alright, so this is going to be our example for our bootstrapping method for forward LIBOR rate. That is, in the event where in the previous example, in this example that we had here, we used forward rate agreements in order to, the definition of forward rate agreements in order to forecast or estimate what our expected future LIBOR rate is going to be. In this case here, what we'd say, well, what if we don't have that available? We may be able to use a forward rate bootstrapping method in order to compute our forward rate, and we can do that because the value of the contract here is going to be equal to 0. And so if we set the present value of all the cash flow equal to 0, we can essentially infer what that forward rate is going to be using our bootstrapping method. Alright, so this wraps up our discussion of bootstrapping method, and let's go back to our slides. And in our example here, we essentially did pretty much the same thing here, where we received the 4% and pay 5%, divide by 2 because semi-annual, notional amount, and then present value. Same thing applies here. Half 5%, 5%, notional amount, present value 0. Half 5.5%, 5%, notional amount, present value, and that's what we get. Now we cannot do that for the last one because we're using a forwarder here that we don't know. And when we add these two components here, this is what we get. And so when we say, well, this component here, which is the present value of the last cash flow, has to be equal to that, for it to be equal to for the sum to be equal to 0, we find that our forward rate is about 5.56% per year. Alright, that's it for our bootstrapping method using forward rate to estimate our forward rate forward LIBOR rate. And also it concludes our discussion of interest rate swaps. Next, what we're going to do is we're going to touch on a different kind of swap agreement, which is a fixed for fixed currency swap. So in the interest rate swaps, we had the following. In our interest rate swap, what we had was a scenario where we had two entities, A and B, and A would say pay a fixed rate of 5% and receive a floating rate, and we call that LIBOR. That was our interest rate swap. Okay, I'm gonna make it look a little nicer there. There we go. Maybe that was our interest rate swap. In our currency swap, or fixed for fixed currency swap, we have the same scenario, but in this case, what's going to happen is we're going to pay a fixed rate, so let's say 5%, on a notional amount that is in one currency. The notional amount may be in US dollar, and it may be 100 million. And in exchange for that, we're going to be receiving another fixed rate, let's say 4% this time, on a notional amount that is in a different currency, let's say in Japanese yen, and it's going to be maybe for 80 million Japanese yen. And the two parties, A and B here, are going to have this exchange occur of the notional amounts at the beginning and at the end of the agreement. That is, when the agreement is entered, there is an exchange of 100 US dollars and 80 million Japanese yen. That exchange occurs today at a specific exchange rate, and we can call that exchange rate E0. At expiration, or a maturity, or the end of the contract here, the same exchange is going to occur again at 100 US dollar million and 80 million Japanese yen. That's not the Japanese yen, that's the British pound. British pounds here, and that exchange is going to occur in the future day at a different exchange rate. Let's call that E1. Now the reason we have these exchanges occurring is because this exchange rate here today is going to be different from that exchange there at that point in the future. And so with interest rate swaps, we did not have that because they had the same currency and the notional was the same, right? So we always worked, say, with $100 million notional, and they both were in the same currency. So if we had an exchange like that of principle, what would happen is A would write a check for 100 million to B, and B will write a check for 100 million to A, because we have the same notional, same currency. Now it doesn't make sense to exchange checks of the same amount, so we're just going to cancel these exchanges for the interest rate swaps. However, for the currency swaps, because the exchange rates are going to be different, we need for these exchanges to occur. Alright, so that's going to be our interest rate, our currency swaps here, and we're going to be looking at an example for this currency swap here in a second. The example we're going to look at is a 5-year agreement to pay a 3% fixed rate if in US dollars on the principal of 15 million US dollars, and receive a 4% another fixed rate in British pound or sterling on the notional amount of 10 million. And so very similar to what we had earlier, where we had two parties, A and B here, and A is going to pay, right, 3% on 15 million US dollars, so that's going to be 3%, and our notional is going to be in US dollars, that's going to be 15 million, and A is going to be receiving 4%. So we're gonna have 4% here on the notional of 10 million, and the currency there is going to be in British pound. That's the idea. With interest rate, with exchange rate swaps, principal is exchanged. In an interest rate swap, principal is not exchanged. We talked about that a second ago. In a currency swap, principal is exchanged at the beginning and at the end of the swap agreement, and this is because of those exchange rate E0 and E1. Oops. E0 and E1 that occur. And we remember how to find those forward exchange rate. Remember that forward exchange rate is our covered interest arbitrage relationship or our interest rate parity relationship. And so we'll look at another example of that, but we looked at that a couple of units ago. In this case, what do we have? We have 15 million that's exchanged for a $10 million. In this case, we are working the 10 million in sterling and the 15 million in US dollars. Now, if we wanted to look at what the exchange rate is when the contract is initiated, we could simply do the ratio of the two, right? And so the ratio of the two would be the 15 million divided by the 10 million, and that would be 1.5 US dollars per British pound. So that's going to be $1.5 per British pound. That would be our E0. And so how would this transaction go? At the end of the year, in this case, we're working with annual payments, not semi-annual payment as usual. What we're going to have is a 3% is going to be paid on the notional of 15 million that we've received, and that 3% of 15 million is going to be this amount, and that's why we have the negative sign here, right? That is the payment of the 3% on that notional amount, and in exchange for that, we're going to be receiving a 4% on the notional amount of 10 million. Now, why do I have the plus here on the 15 million? Because when the contract is initiated, the principal are exchanged, and the principal that is exchanged is 15 million US dollars that I'm receiving. So you look at it as a loan that I'm getting, and in exchange for that loan, I'm making a payment of interest at 3% on that notional amount of 15 million. And I'm going to be making those payments over the life of the agreement, and at expiration on the last day of the agreement, I'm going to be making a payment of the principal or the notional plus the last portion of the interest payment. Okay, and at the same time, I'm going to be receiving 4% on the 10 million British pound, and receiving the 4% throughout. And at the end of the agreement, I'm also going to be receiving the 10 million British pound back, and plus the interest rate, plus the interest that's accumulated there for that period. And so this shows that the notional is exchanged at the end. That shows that the notional is exchanged at the beginning of the period. Now, the typical uses of currency swaps are essentially to convert liabilities in one currency to a liability in another currency. So if you're an international investor or an international merchant, and you typically have purchased products in the UK, and you want to convert those bills that you get in British pound into US dollars, you could enter into these transactions. You could also use those to convert investments, just like we did with interest rate swap. With currency swap, you could also convert investments or assets in one currency in investment or asset in another currency, and that's typically how those are used. Okay. The comparative, and why would you even do that? Because you may have a comparative advantage in one currency versus the other one, right? So the same story that we had in the last unit when we talked about comparative advantage is gonna apply here as well. In this case, we have one company that wants to borrow in Australian dollar. We have another company that wants to borrow in US dollar. And we're going to compare the cost of borrowing across countries or across currencies. And the key difference between the two could simply be that taxes treatment in different countries offer more incentive to one company versus another one. And so GE here could borrow at 5% in the US and at 7.8%, 7.6% in Australia. And Qantas could borrow at 7% in the US and 8% in Australia. Just like what we had earlier with the interest rate swap, we can look at the spread. And so the difference between the two here is going to be 2%. The difference between the two here is only 0.4%. And so we see that there is a difference between these two values, that a mismatch here between these two markets that is of about 1.6%. And that's the 1.6% that could be essentially saved by both parties. And the process will be very similar to what we looked at when we worked with interest rate swaps. And typically, if there is no middleman, they are going to split that. GE is going to save, because GE wants to borrow in Australian dollars, GE is going to save about 0.8%. And Qantas wants to borrow in US dollars, so Qantas is going to save about 0.8%. And the total between the two here, 8% and 8%, is going to give us the 1.6% that we have there. Now, if there is a middleman, which is typically the case, the middleman is going to earn a fee, and the fee may be a couple of basis points, and so they're both not going to save up to 0.8%. They're going to save some again, a portion of that. Now, how do we go about valuing fixed for fixed currency swaps? Well, the valuation for fixed currency swaps could be done using forward rates or as a difference between two bonds. And we're going to work with an example here in a second in order to understand what that valuation is all about for fixed currency swap. We played with that, uses two methods for the interest rate swaps. We're going to look at this for the currency swaps. And our example says that we are working with two currencies, the Japanese yen and the US dollar. And the interest rate in Japan is going to be at 1.5%, and this is continuously compounded. The interest rate in the US is going to be at 2.5% per year, and that's also continuously compounded. Maybe I should actually get my data together here so that I don't have to do the back and forth. Okay, so we're working with Japan and the US, and we have the interest rate. I'm going to call that interest rate in Japan is going to be equal to 1.5%, and the interest rate in the US, I'm going to call that US, is going to be equal to 2.5%. And these rates that we are given here are continuously compounded. Okay. Next, we are looking at a swap agreement that says that we are going to be receiving a fixed rate in yen, and we're going to be paying a fixed rate 4% in dollar, and the payments are made annually. Now, we're not working with semi-annually, we're working with annually. So our swap contract looks something like this. So it is first party, this is huge. Hold on a second, let's see if we can make it. First party here, and we're gonna have the second party here. We will be receiving, I think that's what it says, and we'll be paying. Now what are we doing? We are receiving 3% in yen and paying 4% in dollars. So if we are here, we are receiving 3% in yen. So this is going to be our 3%, and that's going to be in yen. And we are going to do this in yen, and we are paying 3% and 4% in US dollars. So it's going to be 4% here, and this is going to be in US dollar. So that's the agreement that we have, and these are annual payment. And we are also told that the principal amounts are for 10 million US dollars and 8,200 Japanese yen. The life of the contract is for 3 years, and the current exchange rate is at 110 yen per dollar. So 10 versus 120. We're gonna do the following. I'm gonna say the notional is gonna be on 10 million, and our notional here is going to be 108,200 Japanese yen, and the life is for 3 years. So my timeline is going to look something like this. You know, year 1 here, year 2 here, and then year 3. So 1, 2, and 3. And we said that we will be paying 4% on 10 million and receiving 3% on 120 million. Now we are receiving at the end of every year, because it's annual, we are receiving a 120 million, 3% of 120 million. So what is that going to be? 1,000, it's not 120, it's 8,200. 8,200 times 0.03 equal, that's 36. So we will be receiving 36 million Japanese yen. So that's going to be receiving 36 million Japanese yen, but that's in yen, so we need to convert that in US dollar. What does that mean in US dollar? We're going to multiply that by an exchange rate. It's called at E1, the exchange rate at that point in time, and this is going to be in US dollar. In exchange for that, is 36 million that is now converted, because we multiply that by exchange rate. We are going to pay 4% out of 10 million, and so 4% out of 10 million is 0.4. So we're going to be paying, I'm going to use this, minus 0.4, and that's in US dollar. Now this is going to make up the cash flow that we get at that point in time. Remember, we need to find the present rate of that cash flow. However, we only know the spot rate here, which is at 110 yen per dollar. We don't know what the forward rate exchange rate is going to be. We don't know what the forward exchange rate is going to be for the second period. And we don't know what the forward exchange rate is going to be for this third period. Now, remember, it's a fix for fix, so this cash flow is not going to change, right? And so we're still going to get 36 here. We're still going to get 36 here. And each one of these are going to be converted in US dollar by multiplying by the exchange rate. And in exchange for that, we are still going to be paying the same 4% out of 10 million. So 0.4, 0.4. The question that we really need to answer is, what are those exchange rates going to be? Now we remember our covered interest arbitrage relationship, or our interest rate parity relationship, and what that said was the following. It was our forward exchange rate for any period was equal to the spot exchange rate multiplied by the exponential of our domestic interest rate. Actually, I'm going to use something a little different here. Our forward interest rate for any period is going to be equal to our spot exchange rate multiplied by the exponential of the domestic interest rate. So it's going to be RUS minus the foreign interest rate. So we're going to use Japanese yen or Japan. I'm going to use a different color for the Japanese yen here just to make sure that we understand the difference. Or Japan over a period of time that correspond to the T period that we're working here. So T. Now we said that this works well if E0 is direct. And if E0 is indirect, what we have is ET is equal to E0 exponential of, in this case we're going to start with RJ, and then we're going to subtract RUS, and that's going to be it for us. And this would apply if E0 is indirect. Now, what is a direct quote and what is an indirect quote? Now, the indirect is what we have. This is indirect because what we have is the number of foreign currency per domestic currency. That's our indirect quote. Our direct quote is going to be the opposite. It's going to be the number of domestic divided by, or for, not divided by, for one foreign currency. Now, because we're gonna convert our receipt of Japanese yen that we have here to US dollars, what we want is we really want to work with the direct quote, right? Because we need to know how many domestic currency we get for each foreign currency that we are receiving. We're receiving 36 million of the foreign currency. We want to know how much that is in the domestic currency. So we really are interested in the direct quote. And so the relationship between the direct and the indirect is our direct is equal to 1 over the indirect. And so what we have is we need to convert E0 that we have, because now what our E0 that we have here, which is our spot exchange rate, is quoted indirectly. We need to make sure that when we're working with it, we're working with it directly as a direct quote. So our cash flow 1 is going to be the following. Cash flow 1, actually let's just call that 1 here. This is going to be 1, that is going to be 2, and this is going to be 3. And remember, the valuation of the swap in this case is always the present value of these cash flows. So when we do that, we need to find the present value of those cash flows. So 1, which to me is simply going to be the present value of all of that, is going to be the 36 million that I'm receiving 36 million that I'm receiving, that I'm converting to US dollars. That's receiving pound and converting US dollars. And the way I'm going to convert that in US dollars is by using this expression for my forward exchange rate 1. And my forward exchange rate 1, which is E1, is going to be equal to my spot exchange rate, which is 1 over 110 multiplied by the exponential of my domestic interest rate. What is it, the domestic interest rate? It is 2.5%, that's US dollar. So it's 2.5% minus the foreign interest rate, which is at 1.5% for a period of 1 year. And I'm also going to be subtracting from that 0.4 million. This gives me my first cash flow. And this first cash flow has to be discounted at the interest rate in the US because we're in the US. So we're going to discount that at the interest rate in the US by multiplying by the exponential of minus the 2.5% for 1 year. That gives us the present value of that initial cash flow. The second cash flow is going to be the following. I'm still going to get 36. That I'm going to convert, right? Because this is in yen. I'm going to transform that in US dollars. So, but multiply by the spot exchange rate exponential of the domestic interest rate, which is 2.5% minus 1.5% for 2 years this time, minus 0.4. And then I'm going to discount that back to exponential of minus 2.5% for 2 years. And my last cash flow is going to be very similar, 36, and I'm going to convert that into US dollar, 110 exponential of 2.5% minus 1.5% for 3 years minus 0.4 that I have to pay, and I'm going to discount all of that back to the US dollar, back to today, 2.5% for 3 years. So again, what this here is to find the present value. This here is what I have to pay. This here is my exchange rate, and this here is what I receive in Japanese yen. And the same here, that's what I'm receiving in Japanese yen. This is my second exchange rate, and this is what I have to pay. And here what I'm doing is I'm just running the present value. This is what I'm receiving in Japanese yen. This is my third exchange rate. This is what I have to pay in US dollar. This is the present value factor. That's all I'm doing. And finally, I have to add all of this up to find the value of this swap agreement. Now let's do this. 1 is going to be equal to, that's 1 there. Pull my financial calculator here. Actually, pull my financial calculator here. It's created. Let's get it in the memory. So the second function, second function memory. Let's clear that. Second function clear memory. Let's make sure there's nothing in memory there. There's nothing in memory. Okay. What we're gonna do is we're gonna do 0.025. Actually 2.5%. Second function exponential, and that gives us that, or actually forget to put the minus, 2.5% minus, this is what I'm doing, working on that one, and then I'm going to do the exponential, second function exponential. That gives me that. I'm going to store that in the first memory slots. First, store 1. Alright, next I'm going to be working with what's in here, inside out. So it's going to be 1%. So 1%, that's 2.5 minus 1.5, that's 1%. I'm going to do the exponential of that, second function exponential. Multiply that by 36, so times 36 equal, and I'm going to divide that by 110, and 110 equal, that gives me that, and I'm going to subtract 0.4 from that, 0.4 equal, and that gives me that, and I'm going to multiply that by store 1, which is the present value factor. So I'm going to multiply that by recall 1 equal, and so 1 is going to be equal to minus 0.0677, so it's going to be minus 0.0677. Alright, we're going to work with 2 now, and 2 is going to be equal to, we're going to have 2.5%, and then we're going to do multiply by 2 minus present value, right? So it's going to be 2.5% times 2 equal minus, and then we're going to do second function exponential. That's our present value factor. Let's store that, store 1. Alright, so now we're going to do the same thing, find the exchange rate, multiply by 36. And our exchange rate here is going to be 2.5% minus 1%, 1.5%, that's 1%, multiplied by 2 equal, that's 2%, second function exponential, that's that, multiplied by 36 equal, divided by 110 equal, minus 0.4 equal, that gives me that value there, and then we multiply that by the present value factor. So we're going to be multiplying this by recall 1 equal, and our second value there is going to be 0.0696289, so 629 minus 0.0629, and we are going to do 3. And before we work on 3, we need to remember that in our exchange for these currency swaps, what we remember is that the notional amount are exchanged at the end. And if we compute the present value of the cash flows, the future cash flows, the initial amounts are not included in those present value because we are here, but the notional amounts are included at the end. So my cash flow at the end here should be reflecting that notional amount, which is 8,200 here plus the 36, which is what we are receiving. That is the amount of Japanese yen that we are receiving at the end, and we are paying 10 million US dollar, and so we're going to be paying 10 million US dollars. So it's going to be here 10 plus 0.4, and that's going to be a minus there, right? So it's going to be minus 10.4, and we're receiving the 1,200 Japanese yen and $10.4 million. So this here is going to be our principal. So that's going to be the principal, and here those are going to be the interest payment that we are receiving on that last cash flow. So our last cash flow is essentially going to be corrected here to be 1,200 plus 36, and then here is going to be minus 10.4. Alright, so now we can compute our third cash flow. So we're going to do the following. We're going to say 2.5% times 3 equal, make sure you put a negative sign for present value, second function present value, and we're going to store that 1. That's our present value factor. Next, what we're going to do is 1% times 3. That's about 3%, second function exponential. That gives us that. We're going to divide that by 110 equal, and we're going to multiply that by 8,236 equal. That's 11.57. And we're going to subtract 10.4 from it, so minus 10.4 equal. That gives us 1.178, and then we multiply that answer by the present value factor. So multiply by, recall 1 equal. So our present value here is going to be 1.0984. So 1.0934, so 1.09334. And so we have the sum of all of this. That's going to give us the value of our swap. So if we add all of this up, what are we going to have? We're going to have 1.0934934 minus 0.0629 minus 0.0677 equal. So the swap value in this case is going to be equal to 0.9628. So 0.9628, and you remember these are in million dollars. That's going to be the value of our swap agreement there. Now remember that we said we could arrive to these answers in 2 different ways, right? We said we could use this method where we find the present value of the cash flows, or we could treat this as 2 different loans. Now, if I'm going to be getting 3% on 1,200 Japanese yen, what that simply means that today I'm going to be paying 1,200 million Japanese yen. I'm going to be loaning out 1,200 million Japanese yen, and the payment that I'm going to be receiving there are going to be 3%. So it is like issuing a bond, essentially, for a 3% interest rate, or purchasing a bond at the 3% coupon. So coupon rate here is going to be equal to 3%. Our yield to maturity, because I'm in the US, our yield to maturity is going to be equal to my domestic yield to maturity, and my present value or face value is going to be equal to 1,200, and n is going to be equal to 3. And so let's do just that. We're going to create a timeline, and our timeline is going to be identical to what we had earlier, right? So if we're working in the US, we're going to have first year, second year, and third year. Now in US dollar, start with the US bond. With the US bond, how much do we have to pay? Well, we have to paying 0.4, which is what we had here. That's how much we have to pay, right, in US dollar. So we have to pay 0.4 for each one of those years. So it's going to be 0.4 here, 0.4 here, and then we have to pay 10.4 here. That's in US dollar. To find the price of this bond today, what we need to do is to find the present value of these cash flows. And so the present value is going to be equal to this 0.4 that is discounted at because that's the US dollars, so it's going to be 2.5%. I'm going to use a different color here. $0.4. I'm going to do the present value using the US interest rate, so it's minus 2.5%. and that's going to be for 1 year, so multiply by 1, and I'm going to add to that the 0.4 again, and I'm going to do the present value, which is the exponential of minus 2.5%. Remember, this is a percentage for 2 years, and I'm going to add the last cash flow, which is 10.4, multiplied by the present value, which is the exponential of minus 2.5%. In this case, it's going to be for 3 years. This is going to be the present value of the US bond, or the price of the US bond. And remember, this bond would have a 4% coupon, 3 years to maturity. It would have a face value of 10 million, and it would have a payment, therefore, because it's an annual payment, equal to 0.4. Now, if you use your financial calculator to do this, you will not get the same answer, because your financial calculator assumes periodic compounding, right? Annual compounding, for example. But here we're using continuously compounded interest rate. So we have to use these exponential functions. Alright, so that's going to be the price of the US bond. How about the price of the Japanese bond? The price of the Japanese bond, we're going to be, in Japan, we're going to get 36 million Japanese yen, 36 million Japanese yen, and 1236, just like the cash flows I was suggesting earlier. So what do we have? We're going to have 36, and then we're going to do present value. This time is the Japanese yen, so we're going to use the Japanese interest rate, and that's at 1.5%. So minus 1.5% for 1 year, plus the 36 again, and then we're going to do the exponential of the interest rate in Japan, which is 1.5%, minus, because we're computing the present value. Make sure I have that written well. Minus 1.5% for 2 years this time, and we have the last cash flows, which is 1,236, because we have the 1,200 face value that needs to be repaid, plus the interest rate of 36, present value of that again, and that is at the Japanese interest rate, minus 1.5% for 3 years this time. And this will give us the price of the Japanese bond. So we have the price of the US bond and the price of the Japanese bond. All we have to do now is the difference. Now, how do we do the difference? Remember, this, they're the present values. One of the cash flow is received and the other one is paid. We are receiving in Japanese yen, so we're going to be receiving the PV of the Japanese bond, and we're going to be paying the PV of the US bond. And if we're going to make this different, remember that this is in Japanese yen and this is in US dollar. So we're going to have to convert this present value of Japanese bond into US dollar. And remember, these are present values, right? And so those are the values today. So we don't need to find the forward exchange rate. So we don't need E1 here, E2 here, E3. We don't need any of that because we are working at today. So we have E0 that's given. And the way we're going to do that is present value of the Japanese divided by 110. That is going to convert the Japanese yen to US dollar minus the present value of the US bond. And that's going to give us the value of our swap. The value of our currency swap. It's going to achieve the same goal that we achieved here. And in a sense, what this was the present value of that coupon payment on the Japanese bond minus the value of the coupon payment of the Japanese bond minus the value of the coupon payment of the US bond, from which we compute the present value. And then we did that for all three of them. We added them up. So ultimately our answer should be equal to about the same thing that we have here, which should be about 0.9628 million US dollars. And that's how you would find the value of your swap agreement there. All right, let's go back to the slides. And if we go over here, that's essentially a summary of the first method using forward rates. And so if we use forward, we're going to compute the forward exchange rate. So these are going to be a forward exchange rate. This is going to be the US cash flows that are going out. And you notice here that our last cash flows include the principal. And this is the Japanese yen, the yen cash flow that's coming in. Those are the exchange rates. So when we're converting the Japanese cash flows into US dollars, those are the dollar value of the yen. Those are the equivalent here. We subtract from those the US cash flow. That's what we obtain. And then we compute the present value of those differences. We obtain those. Now by adding the present value of differences, we have our swap value. If we were using bonds, we would be using this as coupon payment, and this would be coupon plus face value. We compute the present value using, because this is in the US dollars, using the US interest rate. That's going to be the present value of the US bond. And then we have the Japanese bond, coupon, and then coupon plus face value. This is going to be the present value of the coupon payment, and then this is the price of the Japanese bond. Now the Japanese bond needs to be divided by 110, that is the spot exchange rate, to convert that into US dollar, minus the price of the US dollar bond, and that gives us a value for the swap that is exactly equal to what we had earlier. Now there are other type of currency swaps that exist out there, and we're going to start talking about a few of those and wrap up our discussion here in a few minutes. Alright, so the currency swaps that we've been playing with so far was a fixed for fixed currency swap. Of course, as you can expect, we can have a fixed for floating currency swap. That's equivalent of a fixed for fixed currency swap plus a floating interest rate swap that's added to that. We could have a floating for floating currency swap. Again, that's the equivalent for to a fixed for fixed plus two different floating interest rates that's added to the swap. Again, these are explained a little more, but we're not going to go through an example of working on this. The fixed for fixed was what we wanted to play with. We also talked about the difference between swaps and forward. We said that a swap can be rewarded as a package of forward or a portfolio of forwards. And when the swap is initiated, the swap has a zero value. But typically for some forward contract, you're going to have those that have positive or negative values. So what this means is, if we go back to our cash flow stream here, each one of these package here could be looked at as a forward agreement, right? A forward contract, and this would be another forward contract, and that would be another forward contract. And so each one of these forward contracts could have a positive or negative value. However, when we do the present value of all these forward contracts, when the swap is initiated, we get a value for the swap contract equal to 0. And that's what that's all about. And of course, if the swap agreement has a positive value, a swap contract is entered into by two parties, right? And so if one party is winning, is making a profit, the other party is going to be losing essentially. So if one has a positive value, the other one is going to be realizing a loss there. And so what we have is that dynamic creates what we refer to as credit risk, which is the likelihood of default. And the way we capture, or the way you get exposed to credit risk, is only when, or mostly, not only, when you are entering into this transaction bilaterally. That is, you are working with no central counterparty. So if the agreements are directly between the two parties and there is no middleman, remember what we also had earlier was we had a financial institution that served as the middleman between these two transactions. If there is no middleman, that requires margin, initial margin and variation margin, then you are exposed to credit risk, because if one party starts realizing that they are net negative on the contract, they might default on purpose, right? And if they default on purpose, you stand to lose. That opens up what we refer to as credit risk. And you will have credit risk if you have if your agreement, the swap, has a positive value for you. And so there is exposure if the net value of the outstanding is greater than the collateral posted. That is, if at all there is any collateral. If there is no collateral, then there is no you get essentially exposed to credit risk in a greater proportion. Okay, so what can you do to deal with credit risk? You can engage in credit default swap. And credit default swap is essentially an agreement between two parties where a payment is made in the event of the occurrence of default in this case. So we're gonna have a notional amount that's specified. We're gonna have a maturity that's specified. The default swap is gonna offer protection to the buyer, and he's gonna pay a fixed rate. Because you're purchasing essentially protection, that's functions like insurance. You're gonna have to pay, the buyer is gonna have to pay a fixed rate, which is a premium for the credit default swap, and that premium is going to call a CDS spread, the credit default spread. You think of it as I like to think of this as the premium that you pay on the put option contract. If the reference entity or the organization or the country, if you're buying government bonds, or if you're buying government bonds, that's going to be country. If you're buying corporate bonds, that's going to be the organization. If in the event that they default, the seller of the bond would buy the bond issue by the reference entity for their face value, and the spread payments will stop essentially. That is, when the underlying company or the reference company does default, the seller of the credit default swap essentially is going to retire the loan, the agreement from the buyer, right? So we're going to have two parties. This is the seller of the contract. This is the buyer of the contract. And the buyer has a bond from ABC Inc. And so if ABC Inc. defaults, what the buyer is going to do is going to sell that bond over to the seller of the contract. And that's what all that is all about. And it's going to sell that bond at face value over to the seller of the contract, and this seller is going to take on the loss that comes from the default from ABC Inc. there. The total value, total face value of the bond bought equal the notional amount, and that notional amount will be what is underlying the contract that we had earlier. Alright, and there are other kind of swap agreements. There are many. We're not gonna go through all of this. Go refer to the textbook again to make sure that you look at this and read through them. But they are most function in a very similar way to what we've described. Credit default swaps are unique and they are extensive, so we can dedicate a whole chapter on credit default swaps, but we're not going to do that for this course. Here what we're going to do is just talk about currency swaps and interest rate swaps, and kind of introduce the other type of swap agreement that exists out there, and spend the time to go over this in your textbook, because we're not gonna go through this one at a time here. Alright, so this is going to wrap up our discussions of swap. I will see you in the next video where we will be talking about options. I think that's what we're going to be doing in the next unit. We're going to talk about the properties of options. See you in the next video.